Have you ever wondered what happens to your body in the vast emptiness of space? Picture this, floating about, unhindered by gravity, surrounded by a blanket of stars. Sounds dreamy, right? But what about the effects on your body? How does your heart pump blood, or your muscles function without the resistance of gravity? Are there any unseen dangers lurking within this dreamy scenario? Intriguing questions, aren't they? Well, let's delve into the fascinating science behind it. Now, imagine stepping into a realm where gravity doesn't pull you down. Welcome to the world of zero gravity, a state where the force of gravity is so weak, it's virtually non-existent. It's like stepping into a dream where you can float and glide freely. This isn't a fantastical idea, but a reality for astronauts when they step off this planet and into the vastness of space. So, what happens when you're in this zero-gravity environment? Well, the first thing you'd notice is a sense of weightlessness. Your body, no longer pulled downwards, would feel free and light, as if you've suddenly grown wings. You'd be able to move in any direction with ease, turning a simple movement into a graceful dance. But this feeling of weightlessness doesn't just affect your movements. It also has an immediate impact on your body, particularly your blood flow. On Earth, your heart works against gravity to pump blood upwards to your brain. But in zero gravity, there's no up or down. Your heart doesn't need to work as hard, and blood flow changes. It redistributes evenly around your body, often causing an astronaut's face to appear puffy, a phenomenon affectionately known as moon face. But what about the fluids in your inner ear that help you balance? Without gravity, they float around, leaving you feeling disoriented. That's why astronauts often experience what's known as space sickness during their first few days in space. And let's not forget about your muscles. With no resistance to work against, your muscles can start to feel weak, like you've been laying in bed all day. This is why exercise is crucial for astronauts to maintain their muscle strength. But that's just the start. Zero gravity has more profound effects on our bodies, as we'll see next. From changes in our bone structure to the impacts of space radiation, the human body undergoes a significant transformation when it steps into the realm of zero gravity. So, strap in, because the journey through the human body in space is just getting started. In space, your body faces a new challenge: maintaining muscle and bone health. In the absence of gravity, our bodies no longer need to support their own weight. As a result, our muscles and bones undergo significant changes. This phenomenon is similar to what happens to bedridden patients here on Earth, but it's amplified in the weightlessness of space. Let's start with muscle changes. When we're not using our muscles regularly, they begin to shrink, a process known as atrophy. In space, astronauts aren't using their leg muscles to walk or their back muscles to stand upright. Even their heart, a muscle that works hard to pump blood against gravity, has a lighter workload. As a result, these muscles can lose up to 20% of their mass in just 5 to 11 days in space. Next, let's talk about bones. The human skeleton is a dynamic system, constantly breaking down old bone and building up new bone. On Earth, the stress of gravity helps stimulate this bone remodeling process. But in space, the lack of weight-bearing stress leads to a loss of bone density. Astronauts can lose up to 1 to 2% of their bone mass per month in space, a rate similar to severe osteoporosis on Earth. These changes can have long-term effects. Muscle atrophy can lead to weakness and fatigue, reducing astronauts' physical capabilities. Loss of bone density can increase the risk of fractures, both in space and after returning to Earth. But don't worry, NASA and other space agencies are not sending astronauts into space unprepared. They've developed exercise programs and dietary strategies to help maintain muscle and bone health in space. These include resistance exercises to simulate the effects of gravity, and high-protein diets to help build muscle and bone. So, it's not all fun and floating. There are serious health considerations for astronauts. But with careful planning and preparation, we can ensure our space explorers stay healthy while pushing the boundaries of human exploration. Space is not just empty, it's filled with radiation, and that's a whole different ballgame for our bodies. You see, when we're on Earth, we're protected by a natural shield known as the Earth's magnetic field. This field deflects most of the harmful solar and cosmic radiation, sparing us from their effects. However, the story changes once we venture into space. There, we're exposed to significantly more radiation. This radiation comes from the sun, distant stars, and even cataclysmic cosmic events like supernovae. This radiation isn't something to be taken lightly, as it can have profound effects on the human body. One of the main risks associated with space radiation is an increased likelihood of developing cancer. This is because radiation can damage our DNA, causing mutations that may lead to cancer. While our bodies have mechanisms to repair this damage, they're not always successful. Plus, the more radiation we're exposed to, the greater the chance that these mechanisms will be overwhelmed. But it's not just cancer we need to worry about. Space radiation can also potentially damage the nervous system. It can affect the brain, central nervous system, and heart, leading to potential cognitive impairment, reduced motor function, and cardiovascular disease. Moreover, there's a phenomenon known as the galactic cosmic ray problem. These are high-energy particles that can penetrate the walls of a spacecraft and the human body, causing what's known as microlesions in tissues and cells. Over time, these microlesions could lead to long-term health issues. Of course, scientists and astronauts are not just sitting ducks in the face of this challenge. There are ongoing efforts to develop better shielding and protective measures against space radiation. But as of now, it remains one of the significant hurdles in our quest for long-term space travel and colonization. So, as you can see, space is a harsh environment for the human body. Our bodies, adapted for life on Earth, are not naturally equipped to handle the conditions of space. Despite this, our fascination and curiosity about the cosmos continue to push us to find ways to protect ourselves and thrive in this new frontier. Despite the challenges, the human body has an amazing ability to adapt. In the face of the deep, dark void of space, we are not just helpless victims. No, we are resilient explorers, equipped with an arsenal of tools and the power of adaptability. Let's take a look at how astronauts protect their health and well-being in space. One of the most critical routines they follow is regular exercise. In an environment where your muscles and bones are not constantly working against gravity, they can start to weaken. To counteract this, astronauts spend around 2 hours each day exercising, using specially designed equipment to provide resistance. This exercise regimen doesn't just maintain muscle mass and bone density, it also helps to improve cardiovascular health, which can be affected by the lower gravity environment. It's kind of like a super intense gym session, but with the coolest view imaginable. But what about radiation, you ask? Well, that's a bit trickier. Spacecraft are built with shielding to protect astronauts from some of the radiation, but it's impossible to block it all. However, our bodies have a defense mechanism of their own. Our cells can repair some of the damage caused by radiation. Of course, it's not a perfect system, and prolonged exposure can still lead to health problems. But it's a testament to our natural resilience. And let's not forget about the power of the human mind in all of this. The psychological challenges of living in space are immense, but astronauts train extensively to build the mental toughness required. They learn to manage stress, maintain morale, and work efficiently in a team, even when they're millions of miles from home. So while space poses challenges, we're finding ways to overcome them. The human body, with its remarkable ability to adapt and endure, is just as integral to space exploration as the rockets and spacesuits. We may not have been born for life in space, but we're certainly making a good go of it. So what have we learned about our bodies in space? Quite a lot, actually. Let's run through it, shall we? Firstly, we discovered the fascinating effects of zero gravity. It's not all floating around and easy fetch games, no sir. Zero gravity can cause fluids in our bodies to float, leading to a puffy face and skinny legs, a look we've affectionately dubbed the space chicken. It can also lead to a disorientation, as our brains struggle to determine up from down without the familiar pull of gravity. Next, we delved into the changes in muscle and bone health. Without the need to support our weight, our muscles and bones can start to weaken and lose mass. It's like an enforced, extreme version of skipping leg day at the gym. Then there's space radiation. Unlike on Earth, where we're protected by our planet's magnetic field, in space we're exposed to high levels of radiation. This can increase the risk of cancer and other health problems. It's a bit of a cosmic Russian roulette. Finally, we explored the incredible adaptability of the human body. Despite the challenges, our bodies learn to adapt to the new environment, with shifts in bodily fluids, changes in our senses, and even alterations in our DNA. It's a testament to our biological resilience. Space exploration is pushing the boundaries of our knowledge, and we're learning more about our bodies along the way.